Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface an LDR with a PIC16F877A microcontroller and to turn on and off an LED. But in this case, unlike in the previous video, we are going to have a variable threshold value for the LED blinking. Like whenever LDR value is at certain point, only then the LED will turn on. And we will adjust that value using a potentiometer. So a potentiometer will send the value to the PIC and PIC will compare the value of the potentiometer and the value coming from the LDR. Then on that value, it will turn on and off the LED. For that purpose, we will use a potentiometer to input the threshold value. So let's get started. So guys, this is the PIC16F877A microcontroller I'm going to use. It's a DIP version having 40 pins. This is the LDR sensor easily available in the market. This is a potentiometer I'm going to use. And this is an LED I'm going to use. This potentiometer is 10 kilo ohm, the one I'm using. So I suggest you also use the 10 kilo ohm one. So guys, let's get started. First of all, let's connect the LDR with the PIC. For that purpose, as you can see, this LDR has two pins like this. One pin, you will send it directly to the VCC pin of the PIC. This means you will give 5 volt to this pin of the LDR. And the other pin, you will need a 10 kilo ohm resistor for the other pin. You will connect that pin to the one end of the 10 kilo ohm resistor like this. And then from the same pin, you will take out your ADC value, which will go to the PIC microcontroller. For that purpose, you can use any available analog to digital conversion pin or ADC pin of your PIC. Like this, I am going to use the pin number A0 for that. Now from the other end of the 10 kilo ohm resistor, you will send this pin to the ground of the PIC16F877A microcontroller like this. In this way, your LDR is connected. Remember that LDR has two pins. You can shuffle these two pins as you like, doesn't matter. So you don't have to worry about the longer and shorter pin. You can connect, you can take value this pin as well or this one as well, doesn't matter. So guys, the next thing is the potentiometer. As you know, potentiometer has three pins. The top one, I name it 5 volt. The middle one is the value pin or the one which will go to the ADC pin. And the bottom one is a ground pin. As you can see that 5 volt pin will go to the 5 volt supply of your PIC like this. The center pin, which is the value pin, for this pin you can use any available ADC pin of your PIC. I am going to use the pin number A1 like this, and for the ground pin just send it to the common ground of your PIC like this. In this way our potentiometer is connected as well. Now guys, the third thing is we have an LED. An LED has two pins, one longer and one shorter. You cannot shuffle these two pins. Unlike the LDR, these pins will remain the same. The shorter pin is the ground pin. It will go to the ground. You cannot send the longer pin to the ground, else your LED will not work. So you have to connect the shorter pin to the ground. Now for the longer pin, you will need a 220 ohm resistor. You can use any resistor from 100 to 500 ohm. I am going to use a 220 ohm. You will connect the longer pin to the one end of the 220 ohm resistor. From the other end of the 220 ohm resistor, you can send it to any available digital input output of pin of your PIC microcontroller. In my project, I have pin number D1, that is the pin number 20 of the PIC16F877A microcontroller available. So I'm going to use this pin. If you have any other GPIO pin available, you can use that pin for this purpose. Now guys, this is the total connection for this project. Now what is going to happen is that our LDR will receive the light signal value from the surrounding. Whatever the light is falling on it, it will give a value to the PIC. And then our potentiometer will also send a value to the PIC, but this value is dependent upon the rotation of this knob. The more you rotate this knob, the value will change, increase or decrease depending upon how much you had rotated it. And then we will compare these two values using our programming, and then it will turn on and off LED accordingly. So if the light is too much in the room, I want to change the threshold, then I will simply rotate this potentiometer to change the threshold, and the LED will start to turn off whenever the change threshold is met. So let's get to the programming for your better understanding. Before that, let me introduce you to the hardware as well. So guys, this is the hardware that we have here. This is the potentiometer I'm going to use to adjust the threshold. This is the LDR, and there is our 10 kilo ohm resistor. And this is the LED, one of these LEDs I'm going to use, that is connected to the pin number 20 to turn on and off. So whenever I will move this knob, it will change the threshold value. So if the light in the room increases or decreases and you want to change the threshold without going into the programming, then you can use this knob. So guys, in this way, we will be able to change the threshold of the LDR as well for turning on and off an LED. So let's get to the programming. So guys, this is the micro C4 PIC I'm gonna use. Let me zoom it in for you. So guys, this is micro C4 PIC version 7.2.0 I'm gonna use. You can use the higher version as well. 7.5.0 is also available. So click on File, New Project. This will lead you to this window, New Project. Okay, let me zoom it in again. Sorry, my window activation window just popped up. So you click File. Let me do it again. Click on File, New Project, New File, New Project. Then New Project wizard appears. You click on Next. Write the name of the project, LDR threshold variable learning microcontroller. This is the name of the project I just wrote. Select the path where you want to store the code. I select new codes, then select the microcontroller. PIC16F877A is the one I'm going to use. Select the crystal. I'm going to use a 20 MHz crystal. Click on next and finish. So guys, first of all, before doing anything else, press Ctrl S to save your project. Select the path, click on save. Now guys, first of all, we will need to initialize the ADC pins because our potentiometer and the LDR both work on the ADC. So write down ADC underscore INIT and double bracket like this. This will initialize all the ADC pins of your PIC, give some initialization delay. Then guys, the next thing is we will need to initialize the LED that we had connected at D1. So right now press D.F1 equals to 0. This command will make the LED pin as an output pin because LED works on output pins. Then give the initial state port D.F1 equals to 0. This means that initially the LED must be off. That whenever we turn on the PIC microcontroller, the LED by default is off. Now give some initialization delay. Just copy this delay command here. Now guys, we have the ADC pins for our LDR and potentiometer. We also have our LED initialized. Now we can go to the forever loop. Write down while 1 and inside it start doing the programming. First of all, we will need two variables which will store the values. So I write int rd1 and int rd2, or you can make it even better. I make it int1 as pot, that is the potentiometer value, and this is the LDR value. So now guys, first of all, you take the potentiometer value here and write equal to ADC read, R must be capital like this, read, then a double bracket and then end this command. Now copy this for the other ADC value like this and make it the second variable LDR. This will receive the value for LDR. Now write down the channel. For LDR, our channel is 0. We are using A0 pin, and for the potentiometer, we are using the A1 pin like this. Now guys, this command will read data from the ADC pin, that is the channel 0 for the LDR, and this command will read data for the potentiometer. Now we will compare these two datas. If potentiometer value is greater than, or you can take it the opposite way as well, if LDR value is greater than potentiometer, then LED must turn on. So this LED at port D.F1, which is initially off, will turn on. Else, if the value is lower, if the LDR value is less than the potentiometer value, then the LED will turn off. That is the only other condition. Like this, it will turn off. Now this is a simple code that we just wrote. We click on build. Let's see. So it is giving an error here because on the right we didn't initialize the library. Click on library, expand it and check the ADC library because we are using it. Now see, the error is gone. So our code is built successful. Let me show you what this code is going to do. We have our ADC INIT pin. This will initialize the ADC pins of the PIC for the potentiometer and the LDR. We have pressed D.F1. This will initialize that, like in Arduino case, we write pin mode output. Here we write press D.F1 output. This means the or LED pin is now output pin, and initial state of the LED is 0. Now whenever the LDR value goes greater than the potentiometer value, this pin will turn on, and these two commands will take the value from the sensor. This is our ADC read command, and it will read data from A and 0 because we had written 0 here. This means read data from the pin number 2 of the PIC, and here we have connected the LDR as shown in the presentation. Now for the pod, we had connected it to the pin number A and 2, that is A and 1, sorry, and that is pin number, channel number 1 of your PIC, and it is a pin number 3. So whatever the LD value will come here, ADC value, it will be read by this pin, and then we will compare the two value. If the value of the LDR is greater than the potentiometer value, then the LED will turn on, else it will be off. You can play with this as well. You can make the potentiometer greater. It will just change the direction of the potentiometer rotation. So rest will remain the same. So let's build this code and let's get to the hardware. We go to our PIC3 programming tool now. Let me zoom out. This is the tool. I select the file which we need to burn, click on import, LDR threshold, this is the file, I click on write. Okay, the new file is being written. Let me get to the, okay, the file is written. Now I will power it up using the PIC3 like this. So you can see that the circuit is powered up, but the problem here is that LED is not blinking. LED is not on. This is the LED. Now I rotate the potentiometer knob. See what will happen. See, the LED has turned on. I rotate it further, it turns off. Now the value has changed. Now in this light, there is a light falling on this potentiometer. Now we had set a threshold that this light is not enough to turn on the LDR. Now I change this value. See, it is at the extreme end. It means the value is at minimum. So LDR is like it is in the dark. Now I change this value and see at what rotation point the LED will turn on. Let's see. So LED didn't turn on here. I rotate further. It still didn't turn on. I rotate further. See, the LED turned on here, right here. Now this means this is the threshold point at this light of the room when the LED will turn on. Now I place my finger on the LDR. It should turn off. See, the LED turns off. So this means the LDR threshold has been set for this room. See that it turns off when I place my finger on it. See, it turns on. When I place the finger, it turns off. So this means that we had just set a threshold. Now what I do is that I place my finger on it, it turns off. Now I increase the value a lot. Now the threshold is much higher. See, now it's way more higher. See, now the threshold is too much high that my finger even cannot turn off. Now I place the finger on it, I simply darkened it. See, still the threshold is too high. It is getting light from somewhere which is turning it on. Now I try to lower down the threshold. I rotate in the opposite direction. See at what point the LED will turn off. See, I rotate further. See, it is still on. Now I rotate further. It's on. See, now it turned on at this point. This means that at this point the value is such low for the LDR that potentiometer threshold is not enough to keep it on. Now I change the potentiometer. At the point at which the LED turns on will be the threshold for this amount of light in the room. See, at this point the LED turns on. Now this is the threshold. Now I place my finger on it and see what happens. See, the LED turns off. See, I remove my finger, it turns on. I place it again, it turns off. See, I move it back, it turns on. So guys, this is how you make a system for setting the threshold. In your projects, in various projects, you need this type of setup to do various tasks. When you don't want to change the programming time and time after again for setting the threshold or for calibration purpose, you can make such a circuit where you will use this potentiometer to change the threshold values. In this way, you don't have to go into the programming to change the threshold. So guys, I hope you learned something from this video. Thank you very much for your time and have a nice day.